Okay, let's talk about doors. They're a pretty straightforward concept, right? You've probably been using them every day for your adult life. And if you haven't, you should reconsider how you go to the bathroom. Our door here is made up of a few different chunks. We have a static body, which is a thing that stays in one place, which is our door frame. We have this sliding bit in the middle that will slide up and down when you open the door. And then we have an animation player to play our animation. So if I go in for my transition, there's my door opening up. And then we've got some collision shapes to go along with our static body and our kinematic body. And finally, we have CSG meshes. So these meshes are exactly the same as what we were blocking out our level with the other day. They're just squished in a wee bit slimmer. If we were to walk through creating a new door step by step, let's create a new scene. We will add a static body for our door frame. It'll complain about our lack of a collision shape, so let's add in a collision shape. Our shape is just going to be a box. Why not? We can move this thing up until it's roughly on the floor. So this collision shape is part of our static body, and that's all going to happen on our interactable collision layer instead of the default one. That's because the static body is only going to be used to help the player work out when they're next to a door, whereas our kinematic body that we've got here, that's the actual shape of the door, this is what's going to stop you from being able to walk through. So the kinematic body is on the default collision layer, and it's what blocks the player. So we've put our door on the interactable layer. We're going to turn off the mask. So the layer is what this object is on. So when the player is searching for interactable things, it will be able to find this. The mask is the other things that this thing can find. So because our door never tries to collide with anything else, its mask can be empty. Moving down my example door here, we'll create our kinematic guy next. So we'll add a kinematic body. Again, it'll complain that it has no shapes. We'll also make this a box shape. So we've got our kinematic body with its collision shape under it. They are both down in the ground. So on our kinematic body, we'll just move it up in the Y. Y is the green vertical axis. So it's perfectly centered here. I will also fix this one up. I was slightly below. I've set it to 1, so they sit perfectly on the ground. If we jump on back to here, the next thing we want are some meshes so that we can actually see what's going on. So we'll add under the kinematic body, this is going to be our door. It's a mesh. We'll make it a heap skinnier, and we'll make it skinnier this way as well. So this is our door, and this is our door frame, really. Next thing we want is our door frame mesh. So maybe we'll go back to calling this a door. We'll put in our frame, which will be a CSG box as well. This one will need to move up manually. Again, we'll shrink it right down. Obviously, our door frame shouldn't be the entire width here. We want to cut out a space for the door. So an easy way to do that is just to duplicate this door shape that we've already created. We'll make it a child, and then we can set it to be a subtraction. So now our child here will be subtracting from our door frame. Now because it's slightly smaller, it's inside there, we just need to expand it out so that it actually cuts through. We can probably make it a bit shorter, so that we leave some door frame up the top. And if we hide our original door, or our door inset, our kinematic body bit, you can see that we've made a really chunky door frame. So again, this is exactly what we did with our level mock-out. We have a door frame, which is the whole box. We then add in a child and we'll subtract it, and there's our door frame. And we've got our door piece here is going to slide up and down to play an animation to close things out. Now, because I'm using a kinematic body and it has a collision shape, we don't need to turn on collisions with these CSG shapes. Carrying on down my list here, our door shape we've already covered off. We don't need to worry about that. So the last thing we want is an animation player because we want some sort of animation for the door opening. So if we add an animation player, animations in Godot are kind of amazing. You can animate anything. In this case, we're going to keep it nice and simple. Instead of my example here, which is a bit boring, if we look, all we're doing is grabbing our sliding node, which is our kinematic body here, and we're adjusting its Y translation down into the floor. Which means that if you've got someone trying to walk through under, maybe you've got a tunnel underneath, you can block it off. Which kind of makes for another cool puzzle. But if that's not what you want to be able to use the space under the ground, what we could do is on our door here, we'll reset it back down to the ground point, and then our collision shape can be moved up, and our CSG box can also be moved up, so that everything looks like it's in the same place. But our door down here is at this bottom point, which means if we then scale down the y-axis, our door will slide down until it reaches 0. So just because it's slightly cooler, I guess, than the example that I had, I'm going to create an animation that does that. So in our animation player here, we want to create a new animation. This is door open. Now you can click this add track and you can add whatever you want. What's really cool in here, and I'm not going to touch on it, but you can do a call method, which means you can call a method on a node at a certain point during an animation. So if you want to control shooting your gun, you can play an animation and then you can have the bullet actually come out at exactly the right point in that animation to line up with everything. But instead of adding a track directly here, I'm just going to use the little keys that appear next to everything. So on my door, I want to keyframe the scale. We can make a Bezier curve, why not? It'll look a wee bit more exciting. Now, I don't care about scale X or Z, so we can delete those off, because all we want to do is scale up and down. So here at our 0 point, we are full, a scale of 1. If we move this across to the end here, we can set this down to 0, and I can hit my little keyframe button again. And now I have an animation that we can play of the door just nicely zipping down. So the reason over here I've called this transition instead of like door open, which I just did, was because we can open the door by playing the animation, and then we can close the door by just playing the animation backwards. So maybe transition is a better name. We now have our door animation sliding down, and because the collision shape is a child of our door, it's going to shrink down as well. Now there is a definite problem there in that we are shrinking the scale rather than the extents. Whenever there are extents, you should be using them. So we'll just do the exact same thing. We will take our extents here, we will add them to our animation. We can expand this out so we can see what we're working with. We'll delete X and Z because we don't care. And then here on the last keyframe, we're going to drop this down to 0. So now my scale of the door node and the extents of my collision shape are perfectly in sync all the way down. So we shouldn't have any physics goofiness. I'm going to save this because it's always good to save things. We'll create a tutorial folder, keep it separate, and this will be called door 2. So I've got all the scenes set up that I need. It's time to start writing a script. So if we add a script, I want a C# one, we will call it door 2. By default it'll go into the same folder, that's fine. It inherits all the right stuff, let's hit create. So here's our brand new script. If we compare it across to what we want to create, this is our maximum complication of a door. It's extending spatial, we are extending static body, which is just more accurate. A static body is a spatial. If you have a look, static body inherits from physics body, which inherits from collision object, which inherits from spatial. So although saying this is a spatial is accurate, it would be better to actually map it more accurately. So this should be a static body. It's also implementing the Activatable and Interactable interfaces. So For our example recreation of this, we're going to start with just doing Activatable. So let's copy that, we'll add it as a thing, and we'll go have a look at it. Now, we touched on this the other day, but Activatable just has two methods. You can activate it and you can deactivate it. So create yourself an Activatable interface if you don't have one yet. And then when you come back here, you'll hover over and it will complain that you aren't implementing activate or deactivate. If you use this little light bulb thing, you can say implement interface and it will create them for you. Some other stuff that I think we'll take from the door. We'll export out our animation player because I love exported node paths. I'm going to ignore the is interactable bit for now because that comes into interactable, separate problem. We might as well track whether we're open or not. There's probably no harm in that. So a boolean can only be true or false. Our door is going to start closed. In our ready, we need to do a couple of things here. So the first thing, let's get rid of this boilerplate craft. And we'll move ready to the top just because it's the first thing that runs. So this is plain old boilerplate you've probably seen a million times now. We populate our animation player using our exported node path. The next bit is our assigned animation. You can only play an animation if it is assigned. And that's because in here we have our animation player, we have, in this case, our door open animation. We can have multiple animations, so you might have a very strangely named thing. And then you can pick between them. So when your animation player wants to do something, up here you have a current animation. You can only have one animation at a time. So maybe we want our door open, or we want that mess of stuff. By default, I'm not going to set it here. There seems to be some buggy weirdness where if you set it here, it'll play through the animation, and then whenever you save or import the node, it's going to remember that it's actually at the end here, and you have to make sure you set it back to the start keyframe and then save it. And there is this autoplay, which will make it play when it loads, which is what I would think would trigger that, but I've had some weird behavior. So instead, I'm just going to set it from code. By default, this is not on any animation, and in our ready we're going to grab our animation list, which is this list of all our options. We're going to grab the first one out of it because we're in computer programming land. We index from 0, not from 1, and we're going to set that as our assigned animation. So when the ready runs, it's basically just going to switch this on, but it's not going to play it. So I'm going to set this back to stop because that's infuriating. So if we go through the rest of what the door does here, if we are open, you can't activate the door again. We're not implementing a close function. We play an animation and then we say that we are open. So let's just throw that in here. So when you activate the door, bam, you're done. Deactivate here does the exact opposite. We come in, we play our animation backwards. That's what we were looking at before. You can play this forward to open it, or you can play it backwards to close the door. So deactivating the door will close it. So right here is all the code that you need to have a door open and close. The one last thing we need to do is compile this, or you could hit run, which will compile it for you. If we open up my test scene from the other day, it's got our character, it's got our weird little thing here. Let's add our door 2. Slide it over somewhere, stick a door kind of in front of my tunnel so you can't get through the tunnel. Brilliant. Also, all the colors are the same so you don't realize there is a tunnel back there. If we were to play right now, our game's going to crash because that ready is going to run and we're going to get an error saying we got a null reference exception because the node path is null. Right there, it doesn't give away too much. If you expand this out, you can see that it's a node path problem. And then if you go down far enough, it's caused by line 15 in my door2 script. door2.cs line 15. If we toggle over to that, line 15, we're trying to get our animation player node path, but we didn't set that. So we come back, we open up our door2 here, and we'll set this to be our animation player. Save that, door2 needs saving, and we'll play this level again. And this time it boots up fine. My door that you can't see at all is there. If I try to walk through it, I can't. So obviously a door that does absolutely nothing is kind of useless. We've written the code to let the door open, but there's nothing calling that code. Let's move on to the next step. I know I called this tutorial doors. This is doors and tripwires, I guess. Pressure plates. If we look at my test map here, I've got this pressure plate thing here. We'll just copy this. So my pressure plate here is a spatial. It has a mesh instance, which draws somewhere. So I was completely lost there. My camera was pointing somewhere weird. Let's say it's over here. Remember, you can press F to focus. Brings me back to where I want to be. I have a mesh here. It's got a weird bluish material, which we can actually see here. It's just a spatial material. I set the color to blue. That's all that's changed. We then have an area. The area is just above. It reaches up, so you can sort of jump and it'll activate just before you actually touch it. You could shrink this up or down as much as you want by adjusting the collision shape. And then our area, you can see the little signal symbol here. We have a body entered and a body exited. And if we have a look at the script, really simple. Your body enters, your body exits, and it will emit some signals. Now it does seem kind of redundant, I suppose, having it set up this way, because we've effectively just re-implemented the area code base. We emit a signal when the on-area body entered signal is emitted, and the same this way around. Originally, I was going to do some animations and stuff on the pressure plate. You could play sound effects when you step onto it, so that's why I've created it as its own script here. And then you'll see in the test map here, when you step on the pressure plate, it emits signals using these. Now, because it's a spatial, you'll see that my pressure plate doesn't have the area signals. That was also an intentional thing. I didn't want you to wire up without going through this activate and deactivate in case we want to play sound effects when you activate a pressure plate or something like that. For a real simple, let's just make a little scene here work. Let's create something in the scene and then we'll promote it, I guess, into a proper class like our pressure plate. So we'll start off, let's just add let's do it the same. We'll create a spatial. This is going to be our pressure plate. Under that, we will add an area. The area immediately begins to complain that there's no collisions. So let's create a collision shape. This should be getting pretty familiar by now. You want to come over and give it a shape. Let's make it a box shape because they're simple. We'll move our pressure plate. Now you can grab by the axes to go in an individual one, or you can grab the special colored squares in here that do everywhere except for the axis of its color. So this will let me drag anywhere except for the Y, which means that if I let go of that, it's actually gone miles away. So if I grab this little square, I can move it right here, say. Now we haven't given it any sort of display, but if we look at our collision shape, we can see that it's in front of the door. It's covering off the whole door. It's good enough, right? You can vaguely see the shapes. Covers off in front of the door and a fair way behind it. We could shrink that down, I guess, and move it a wee bit closer. So if you were actually creating doors that open when you come up to them, I would do all of this inside my door scene. Theoretically, this pressure plate could be way over here somewhere, right? It's just going to be hard to find. So in our collision shape here, in our area, we can wire up these signals. So let's say when you enter an area, we will connect to that door right there. Now this is where the tooling kind of breaks down a wee bit. By default, it wants to create a specifically named method in our door script. Our door script already actually has everything we want, right? In our door script here, we have an activate, and if we call activate, it'll do the things. So we can just replace this, and we can hit connect. Unfortunately, it jumps over into our script, which is normally a good thing because normally it would create a method and it's handy. In our case, we didn't want it to, we just want to carry on with our life. And we will play our scene again. And now if I walk up to the door, nothing happens. Why did nothing happen? So what I've configured here is when your shape enters, we don't care about shape entering, that was the wrong thing. Let's disconnect that. Body entered. My player has a body. When they enter this, we want to connect it to the door. And we want to call activate. Activate again. Save that. Let's try this time. And nothing happened again. How sad. Something's going wrong with my debugger now, which is handy. Okay, so the reason I couldn't understand what the hell was going on here is because I wasn't paying attention. You'll note in our pressure plate example, I have an on activated signal and an on deactivated signal, and I can wire that up to my doors activate and everything's fine. But in my area, when I try to wire up body entered to my activate method, everything breaks. So the reason for that, if we look at our pressure plate, this activate is called from an on activated signal, and there are no arguments. In my area here, I have an argument. So when it tries to find an activate method that takes a single argument of type node, it fails to find it, which is why this is breaking. All of that is to say that actually the script on my pressure plate is important. So let's convert this into a root node. So we can say save branch as scene, and we will go into tutorial again. Let's call this pressure plate 2 again to differentiate it. Why not? Save it. So we now have a pressure plate scene. We'll call it pressure plate 2. It again doesn't have any visuals. It's just an area and a collision box. We can add a script for it. And we're just going to do exactly what we did with the original pressure plate script. So on my area here, we can do body entered. We can connect it to our pressure plate script. Let's call it on body entered. And then we'll do the same thing for exited. Why not? So we've wired up our signals looking to find on body entered and on body exited. In my script here, I haven't implemented those, so it's going to explode. Instead of doing it all from scratch, I'm going to be lazy and open my pressure plate. Just grab these two methods. So we have things. I didn't use area, so we need to pull that out. I've got my binding set up. Now we're going to have to create a signal for on activated and on deactivated. Again, I'll just steal them from here because that seems like the easiest thing to do. C# signals are going to be public delegate void methods. We give them the signal attribute, and then when we want to call them, we say emit signal, and we pass through the name. If I don't drag stuff around, I won't break as much code. Now, the reason I use name of, because if we look at emit signal here, it takes a string with the name of the signal. You could say emit the signal on activated and everything would work just fine. But what if I want to rename this? If I want to change it to on potato, this is going to break because it's going to try and emit a signal that no longer exists. Whereas if I go back to using name of, I can rename this however I want, on potato. It updates our name of, all of our code will continue to work. So that's one of the reasons I like C#. That name of, brilliant. Much better than passing strings everywhere. So let's go back to on activated. It's boring, but it tells you what's happening. We've already wired up so that our body enters, goes into these. And again, these methods take an argument, which means that they will actually work with our body entered signal here. And then they will emit some signals. I need to build in order to see them. But they will emit signals that don't have arguments. So we come back to our problem level. Here is our pressure plate 2. We can bind its on activated to our doors activate method. and it'll jump back in, we don't care. So here we go, running up the scene. If I run up to the door now, doesn't matter, it triggered by default. Now, you might be wondering, why the hell would that trigger? I didn't walk up to it. That's not fair. Our pressure plate here, its shape is going down into the ground a wee bit, and our ground plane here happens to have collisions enabled, and it's on layer 1. So what's happening is I'm colliding with the ground, and because I'm colliding with the ground, it activates immediately when the game starts up. The easiest option, I suppose, would be to lift our collision shape up into the air, so it can't collide with anything. Let's fire up that level. And now when we approach the door, we enter it, it triggers, we can go through the door. So that was surprisingly painful. One last thing that we could do, because this is a very homogeneous map right now, let's look at some material stuff. So if we go into our door, we have our door frame. It's probably the key one actually. If our door frame stands out, then we'll know where we're going. So we have our door frame. It has a material slot, and we can create a new spatial material. This spatial material gives you a whole bunch of stuff you can do. We're just going to change its color. So under albedo here, we have a color. Let's just make that purple. Now our door will have a purple door frame, so it'll stand out a bunch. So if we come back to our problem map, bam, you can see where a door is. If we move it back a bit closer to the wall, it won't be quite so ridiculous. See the jittering on the top? That's because the sliding part of the door that goes up and down and the very top of a door frame are at the exact same spot. All we need to do is head back to our door, and either we make our door frame a fraction taller, or we make our slidey door bit a fraction shorter. In this case, let's just add 2.01. It won't need to be much. Almost nothing, just so they're not at the exact same level. And that problem will go away. So if we jump back in, we can now actually see where our door is. You'll note that when we come up, we can see through the map. We disappear into the depths of the ground. My door's not aligned particularly well, but that's fine. That disappearing problem is because in our door we have the subtractor thing going down into the ground, so it's subtracting from down there. Easy solution, I guess, is we set our transform back to 0. You can just have a wee lip. You could shrink our height a wee bit more from this point to get something you want. We do need to bring the transform down. I don't know, you have a play with it, but that'll do. We can have a little door frame lip as you come through. That's not going to hurt anyone. Look at that. Disappears down. Wham. We run through. So now you've created a door. You've created a pressure plate to open it. The only thing left is we could go to our pressure plate here. We can bind up our deactivate to the door's deactivate method. Jump back to our code. Run our scene. Now when we enter the thing, the door opens. When we leave, the door closes. So now we open it and then you run. And if you're not fast enough, you'll get hit by the door on your way and get knocked up on top of the map. And now we're off into glitchy exploit land. And that's fun. It might not be what you're going for, but it is pretty cool. So to quickly recap what we've gone through, we have created a door which has a bunch of nodes and some animations. We've implemented the activatable interface, and we've used signals to hook into that and actually make our door open when you walk onto a pressure plate. The only thing left is maybe to add something visible to your pressure plate. I'm going to leave that as an exercise for you, but if you need a wee hint, my pressure plate over here has a mesh instance. Kind of gives it away there, but it means that you can go make shape. Maybe you can do something more interesting. Make it a box shape, and when you step on it, have it animate down flat. Going and doing those exercises is going to help bed in what we've learned. Let's be honest, it's been a very long tutorial just to learn how to stick a door into a wall and open that door. So our next tutorial is probably going to go through how we can interact with the door directly as a player, rather than relying on a pressure plate to do it for us. So come on back for that later.